All right, welcome to Complex Numbers. Let's get started. So the two questions I want to answer today in your essential questions is what is a complex number and what is I? So a complex number has a real part and an imaginary part. So for example, 5 plus 2i would be a complex number. 5 is the real part and 2i is the imaginary part. So a number that we've been working with, like say 2, is still a complex number because the imaginary part is 0. Right? So if we have 0i, so this would be your imaginary part. Your real part is 2, so you just work with the number 2. But now we're going to start working with this imaginary part, and so that's what our complex number is. So what I stands for is the square root of -1. And we've never been able to take the square root of negative numbers, but now we can because I is going to stand for the square root of a negative number, -1. So this is really important. Don't forget it. You're going to need to memorize it. So if we know I is the square root of -1, then I squared, we could figure that out because you can break that into I times I. Well, if I is the square root of -1, then the square root of -1 times the square root of -1 is just -1. So I squared is -1. Another thing you'll have to definitely memorize. All right, so let's look at some examples of taking square roots. So square root of 9 would be 3. We know that. Okay, but now the square root of -9, before we would say you couldn't take that, but now we can because we can simplify the square root of 9 into the square root of +9 times the square root of -1 because 9 times -1 is still -9. And we know the square root of 9, which is 3. And we also know the square root of -1 now because it's I. Right, so the square root of 4 we know is 2. The square root of -4 would be 2i. Which again, you would split it into the square root of 4 times the square root of -1. This is 2. Square root of -1, like we're just learning, is I. So since we can take the square roots of negative numbers now, we can also solve quadratics a little bit easier because now sometimes our x's will be imaginary numbers. So x squared equals 9. We know in order to find x, we could, what we've been doing is putting it in standard form and factoring it. Okay. In this example, if let's say I didn't want to put it in standard form and I just wanted to take the square root, which you can't do this all the time, okay, but we could because the square root of x squared is just x and the square root of 9 is plus or minus 3. So we get the same answer as if we put this in standard form and factored it and solved for x. Now, when we have the x squared equals -9, we can do that because taking the square root of both, square root of x squared is x, square root of -9, like we saw before, was 3i. So plus or minus 3i. All right, so again here, x squared equals 4. We can take the square root. X is plus or minus 2. And now again, we can take the square root here. And since now we can take the square root of negative numbers, we have plus or minus 2i. So this is another way to find roots for this quadratic. For this quadratic, it's x equals plus or minus 3i, plus or minus 3, plus or minus 2, plus or minus 2i. Now remember on a graph what that means, like for this example, -2 and +2, that means your graph looks like this, right? So these would be your roots, -2 and +2. Well, over here, this is plus or minus 2i, so that means they're imaginary. So this graph doesn't actually have real roots. They don't cross on the x-axis. So before, again, when we would find a quadratic and graph it, we would say it didn't have roots. But now you'll actually be able to tell me the imaginary roots that it has. Okay, so another thing we need to know is how to perform operations with complex numbers. So what's kind of nice about these, it kind of works the same way as the binomials. If we're adding a complex number, remember this is the real number and the imaginary unit. So this is one complex number. So if we're adding one complex number plus another complex number, you're just combining your like terms. So 3 plus 6 is 9, and then a positive 4i minus 9i is negative 5i. So this complex number plus this complex number is this complex number, the real and the imaginary unit. So with subtracting, when we're subtracting a complex number and another complex number, you're actually going to distribute that negative sign, and then you can combine your like terms. So distribute the negative sign and then combine like terms just like you did when you were adding them. So this becomes negative 6 plus 9i. So now we have one complex number and another one that we're just combining our like terms. So we have 3 and negative 6 is negative 3, and positive 4i and a positive 9i is now positive 13i. So the last operation is if we want to multiply one complex number times another complex number. And again, this kind of works like the binomials. You're just going to FOIL. Then you're going to combine your like terms. There's actually one more step here, and I'm going to show you as I do this example. So we're FOILing it. 3 times 6, that's 18. 3 times negative 9, that's negative 27i. Sorry, 3 times negative 9i is negative 27i. And then we have 4i times 6 is positive 24i. And 4i times negative 9i would be negative 36i squared. Okay, so don't forget that an I times an I works like the X times an X. 4i times negative 9i is negative 36i squared. And then we want to combine our like terms. So we just FOILed. Now let's combine the like terms. Let's put these two i's together. So now we have, let's see, 18 minus 3i minus 36i squared. So here's where the next step comes in. We know from the other slide that I squared equals negative 1. So we want to substitute in or replace negative 1, or replace the I squared with negative 1. So now I've got 18 minus 3i minus 36, and instead of I squared, I've got a negative 1. Okay, so replace I squared with negative 1. This is really important because you cannot leave I squared in an answer because we know what I squared represents. And so negative 36 times negative 1 is positive 36, and then we just combine whatever we can. 18 plus 36 would be 54 minus 3i. So the multiplying the complex numbers is a little bit longer. We've got to do a couple extra steps. And then don't forget, never ever leave I squared in an answer, okay, because you can always plug in negative 1. That's it. Thanks for watching. See you later.